I've not always worked on climate. Before I worked on climate, I worked mostly on earthquakes and tsunamis. I think back to when I worked on the tsunami. I think of the young parents standing on that beach, looking as the wave rolled in, standing and looking. And so many people ask, why did they not run? But the answer is very, very clear. The earth is curved. If the wave is far enough away, you don't see its size. You have no impression of scale. No one would see it. When people watch videos now, they shout, run, run, run. But nobody shouted run. Being a climate scientist today is like standing on that beach shouting run, 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 and nobody turns. Everybody stays staring at the wave until it's too late. That's what it feels like to be a climate scientist now. We are shouting run. I have several purposes for going to COP26 in Glasgow. One purpose is to participate in and help at the Cryosphere pavilion, cryosphere meaning snow and ice, where we have a task, and that is to explain that when snow and ice melt and sea level rises, that in our human perspectives is a permanent change, which is a driving force for us to be extra careful to keep that 1.5 degrees goal in reach. The climate is guided by the carbon cycle. And when we're thinking about the climate crisis, it's important we think about the role of rocks. Why? Because the carbon that we're putting in the atmosphere comes from rocks. So what happens in the geological carbon cycle is as follows. Carbon ultimately reaches the atmosphere from volcanoes. That carbon gets into the atmosphere in the form of carbon dioxide, a certain amount every year. The same amount every year, on average, is removed from the atmosphere. And that's removed by what we call weathering, the weathering of rocks. And what that means is rocks actually dissolve very, very slowly. And when they dissolve, not only the rock, but the carbon dioxide in the atmosphere dissolve together. That carbon dioxide in the atmosphere, it then becomes bicarbonate, which is soluble, and it's carried by rivers down to oceans, where it ultimately precipitates, forming limestones. And it's back to being a rock again. That is the geological carbon cycle. Well, the problem when humans start burning carbon is that we're taking lots of that geological carbon and putting it in the atmosphere far, far faster, 1,000 times faster than the natural geological processes can remove it. So that means that the amount in the atmosphere just goes up, up, up. And that's what's causing global warming, and that's what's behind the climate crisis. This meeting is vital. This meeting is hugely important. This meeting, we can hope, will define the rule book whereby the Paris Agreement is put properly into action. This meeting has the potential for being very important. It has the potential for taking us a big step forward. On a personal level, was the feeling of being completely lost when I go in there. Completely lost. Wandering around like a giant exhibition where I didn't see much science. Until thankfully, our Cryosphere pavilion was a little microcosm of science within this giant event, which seems to be profiling lots of successes, which I don't really feel are justified.
So I am pleased today to be able to introduce Alasdair Skelton, who is the co-director of the Boland Center in Stockholm University, who will provide you with a new perspective on this issue. So, Alasdair, the podium is yours.
Thank you very much indeed, Mark. Thanks for the warm welcome. And nice to see you all here.
Solar geoengineering is when we as humans try to mimic volcanoes. When volcanoes have an eruption, it's not just lava that comes out, it's also sulfate particles. They get fired up high in the atmosphere, and they actually make the Earth cooler. And that's because those little particles are like mirrors, and they reflect the heat from the sun, so the Earth cools down. We know that. We've seen it's happened in the past. So when I say we mimic volcanoes, we would do the same thing. We'd fly masses of sulfate particles or other substances up into the higher part of the atmosphere to cool the Earth down. And that all sounds great until you actually realize that there are other consequences, because those particles don't just affect temperature. That mirroring effect also affects weather patterns. It affects rainfall. And indeed, rainfall lowers. There's less rainfall. We know that because that's what happened after volcanic eruptions. And what does that mean? Less rainfall means crop failures. We put our water resources at risk, and it's not great for biodiversity. And then there's another problem, because those particles don't stay in the atmosphere very long. So that means you've got to keep adding to them. So you make a permanent contract that from this day forward, we will always have to put those particles up in the atmosphere. Because if we stop doing it, the temperature will just shoot up again. And that temperature shooting up again will be dangerously fast and will be very, very difficult for species on Earth to adapt to. That's called a terminal shock. And that is something we must avoid. I have enormous admiration for the young protesters, but I feel that they are carrying a burden that should not be on their shoulders. They're acting because we're not acting as grown-ups. And that's not what we should be doing as parents. So often when I see the youth protesters, I simply feel ashamed. The young protesters have come here almost entirely by train, and others have come from all over the world to this country to fight for their futures. And I want them to have a day off, because I'm not just a scientist, I'm also a parent, and I care about them. And one day walking in the beautiful hills of Scotland, I think it's good for them, and it's something I can give them because this is my country. I know where those hills are, and I can show them to them.
When you get to the path, stop. Do you know why? Because it's the shooting range.
Oh yeah, don't go shot.
I'm going to go to the path, make sure nobody goes past it. How sweet the sound that saved the wretch like me.
The time I spend with the young protesters, listening to them and teaching them, makes me see a clear and well-defined purpose of the science that I am doing as a geologist. Because the science of geology underpins the crisis we find ourselves in. And a simple understanding of geological time is all any of us need to understand that we are on the brink of a really serious crisis.
If you normal rot today, take it, break it, it would snap. You couldn't actually fold it. It has to be really hot. So that tells you that must have happened very deep down. So that happened.
I see no problem supporting the youth protesters, provided one knows one's place. I'm a scientist and I talk science and scientific truth. I do not want to run around with billboards. That's not my place. So long as I hold myself within the bounds of scientist to support the young protesters by teaching them, speaking at their meetings if they need a scientific input, and I think they do, and when they need a break, providing them somewhere to turn to. I think that is both scientist and human. The giant step forward we need is a massive cut in emissions. And that's really not written down in what's coming out of the COP. At the moment, a key issue is fossil fuel subsidies. There was an initial very strong wording on that, phasing them out. And that wording has gotten weaker and weaker. A moment that gave me hope at the COP meeting was dancing a ceilidh in the streets with the young protesters. Why would that give me hope? Because it's a beautiful way to protest. There's a silent beauty in a dance conveying love into that meeting where lots of parents, we can call them politicians, are trying desperately to have the courage to make the right decisions. That warmth being pushed into the COP from people who genuinely care, that's going to be creating a beautiful future. It will happen. That gives me hope.